Well, we've been talking about infrastructure, especially as it relates to data within large organizations. One of the things that I hear is both, science is data starved. When we're trying to build these new models, we just don't have enough data sets, and we don't have the privilege of these, Anthropics and OpenAIs that can just scrape the web and, train these models. I also hear folks saying we are overwhelmed with data and we don't know what to do with it, and there's data everywhere and we don't even know where it is. So what's the true story here? Where are we?
Well, the answer is always it depends. No, but I think you see both problems actually, and you can see both problems at the same company, and sometimes even in like the same problem space, where in most cases we don't have enough data. A lot of science that's done, a lot of biology and chemistry that's done is very low throughput, right? You're creating maybe a few dozen molecules a week, and you're testing it. That's like a very small amount of data. Sometimes you can create really large data sets, and we can talk about that too. But like a lot of science that gets done is still very manual. It's one person doing something, and so yeah, the data is actually pretty small. The trouble is sometimes you can do something in a kind of like maybe you're only testing one thing, but you can do it in such a way that you get a lot of different measurements. So you sequence the genome of a single cell. You can get like a pretty large measurement from that. And when you scale it up to all the cells in a certain tissue, right? Like, okay, the low throughput is you have one tissue. The high throughput is now you have tens of thousands of cells and hundreds of thousands, millions of measurements. And so you can very quickly get really large data. I think this is what makes biological data actually really interesting and hard to build software for, is you have to deal with both of those things. So the data shape is quite unique. You're not just plugging everything into Snowflake and querying it, right? Or just doing everything kind of manually and keeping it in your head. The last point I'll say here is even the very large data. So there is a recent single cell data set with 100 million different cells that were measured that was released. Large numbers. There's, I don't know, many petabytes of sequencing data out there. The problem is that's actually small in comparison to the complexity and dimensionality of biological data. So even when you have really, really large data, there's a ton of sequencing data out there. That's actually like still a pretty small amount of data compared to how complex biology is. And so I think that's kind of the fundamental problem is you have small data, you have big data, but the big data is still small in comparison to like what truly needs to be understood in order to engineer these systems.